Welcome to The Explainer. Today, we are jumping into one of the most dramatic stories in the history of science. It's a 150-year battle of ideas that completely, and I mean completely, redefined our place in the cosmos.
Okay, so let's just think about this for a second. For over a millennium and a half, pretty much all of humanity believed one thing about the universe. It was considered absolute, undeniable truth, and it was completely wrong. So this is the story of how that truth got unraveled. All right, so our story kicks off with a model of the universe that was, you have to admit, brilliant. It was accepted by pretty much everyone, and it lasted for an incredible 1,500 years. This was the Ptolemaic, or geocentric model. It was perfected way back in the 2nd century by the astronomer Ptolemy in his masterpiece, a book called The Almagest, which literally means the greatest. And it was an elegant idea, right? It made sense. The Earth is stationary, right here in the middle, and everything, the sun, the moon, the planets, they all revolve around us. It put humanity right at the center of everything, which, fit perfectly with the way people saw the world back then. But there was a bit of a glitch in the system. A major flaw, actually. It couldn't really explain this really weird thing called retrograde motion. That's when you're watching a planet like Mars, and it seems to just stop, move backward for a bit, and then go forward again. So to fix this, astronomers came up with a really clever but also really complicated patch. They called this patch epicycles. And what that means is, basically, circles on top of circles. So the idea was, a planet moves along its own little circle, and that little circle moves along the bigger orbit around the Earth. You can kind of picture a planet on a celestial Ferris wheel that's also attached to a giant merry-go-round. Yeah, it made the math work, sort of, but it also made this once elegant universe feel really clunky and unnecessarily complex. And all this complexity, this patching and fixing, it really bothered a Polish astronomer named Nicholas Copernicus. He looked at all these wheels on wheels and thought, there has to be a better way. And he had a radical, much simpler idea that was about to kick off a revolution. And this slide just lays it out perfectly. Copernicus proposed what we call a heliocentric, or sun-centered model. It was so much simpler, way more elegant, but when he finally published his book, De Revolutionibus, in 1543, the world just wasn't ready. I mean, it was largely condemned or ignored. In fact, the entire first print run of 400 copies didn't even sell out. Nobody wanted it. So here's the crucial point, right? Copernicus had the big idea, but he was missing the proof. He couldn't prove it. It would actually take a whole new generation of scientists, each with their own unique tool, to finally show that he was right all along. So first up in this lineup is Tycho Brahe. And let me tell you, this guy was a character. He was an eccentric Danish nobleman, famous for his incredible work and, yes, a metal nose he wore after he lost his own in a duel over a math formula. You can't make this stuff up. Then, in 1572, Tycho saw something that, according to the old model, was literally impossible. A new star, a nova stella, blazing in the sky where there was nothing before. This discovery just shattered that core belief that the heavens were perfect and unchanging. It was a major blow to the whole Ptolemaic system. But his real, lasting gift to this whole revolution wasn't a theory, it was data. For decades, from his own personal island observatory, he made the most precise, the most comprehensive observations of stars and planets the world had ever seen. He created a treasure trove of information for the next person in our story. And that person was Johannes Kepler. Kepler was this brilliant but also kind of troubled mathematician. He got his hands on Tycho's data and spent years, nearly a decade, doing these brutal page-after-page calculations. And then he had his breakthrough. It was the mathematical key that unlocked the whole thing. Planets don't move in perfect circles. They move in ellipses. Now get this, at the exact same time Kepler was figuring out the math, a new technology was popping up in Italy that would provide the visual proof. Galileo Galilei didn't actually invent the telescope, but he had the absolutely brilliant idea to point it up at the sky. And what he saw, well, it changed everything. Looking through his telescope, he saw things that just completely contradicted the old model. He saw moons orbiting Jupiter. I mean, that proved not everything revolves around the Earth. He saw Venus going through phases, just like our moon does, which was physically impossible in the geocentric system. And he saw that the moon wasn't some perfect, smooth orb. It was covered in mountains and craters. This was visual, undeniable proof that the old ideas were simply wrong. But, and this is a big but, this revolutionary proof came at a huge personal cost. For daring to defend the Copernican system, Galileo's work was declared heresy. He was tried by the Inquisition, he was forced to recant everything he had discovered under threat of torture, and he spent the rest of his life under house arrest. So, okay, let's recap. We have a radical idea, we have precise data, we have the right math, and we have visual proof. But there was still this one giant question hanging over everything. Why? Why did the universe work this way? And for that answer, we have to turn to our final hero. You see, this is the final, crucial piece of the puzzle. Copernicus, Kepler, and Galileo were amazing at describing how the planets moved, but it took Isaac Newton to finally explain why they moved that way. He explained the force behind it all. In his absolutely monumental work, the Principia Mathematica, published in 1687, Newton laid out his law of universal gravitation. It was a single, elegant equation that explained that the same force that makes an apple fall to the ground right here on Earth is the exact same force that keeps the planets in orbit around the sun.
Newton had done it. He had united the heavens and the earth under a single physical law. The poet Alexander Pope really summed it up perfectly when he wrote, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light."
And when you look at this chart, it really puts it all in perspective, doesn't it? A 1,500-year-old worldview, an idea that defined reality for generations of people, was completely taken apart and replaced in just 150 years. That is a breathtaking pace for such a huge shift in how we see everything. So, what's the big takeaway from this incredible story? Well, it shows that science isn't just a straight line to the truth. It's a messy, very human process. It shows that new tools, whether it's better data or a new invention like the telescope, can completely change the game. It proves that real progress requires us to challenge our most deeply held beliefs. And, maybe most importantly, that great breakthroughs are almost always built on the work of those who came before.
And that kind of leaves us with one last, humbling question. This whole revolution happened because just a few people dared to question what was considered an absolute truth. So it really makes you wonder, what fundamental truth do we all take for granted today that future generations might look back on and say, how could they have possibly believed that?